Today, I shall teach you about the nitration of benzene, which is the act of putting an NO2 group on a benzene ring. And you do that by using HNO3, nitric acid, and H2SO4, which is sulfuric acid. And you end up with this NO2 group. These two are the same thing, attached to the benzene ring. So first, I drew out the Lewis structures for the acids. And since one of them is stronger than the other, one will act like an acid and one will act like a base. Sulfuric acid is stronger than nitric acid, of course, so this will act like a base and will steal one of these protons. So the lone pair of this oxygen will actually go out here, like this, and like this. And so now a nitric acid will look like this. And the sulfuric acid will just look like the same thing without the hydrogen. And it also has a negative charge on this oxygen. But that's not important. Anyways, since this part over here is a good leaving group now, it leaves. And it does that like this. So this oxygen and two hydrogens, once it leaves, it becomes H2O, so it's stable. That's why it's a good leaving group, because it's stable when it leaves. First, the oxygen and two hydrogen leaving groups, they leave. And now nitrogen only has 3 bonds to it. So this lone pair from this oxygen comes down to form another bond with the nitrogen. And this forms an NO2 group, which is positively charged, and is also called a nitronium ion. And the nitronium ion is a very strong electrophile. It's thirsting for electrons. So next, you have the benzene, which is a weak nucleophile. But since the NO2 is such a strong, it's so down bad for electrons, the benzene will give it electrons. So the electrons in this pi thing, this pi bond, will go boom to the nitrogen. Then nitrogen will have 5 bonds. That can happen. So one of these electrons will go back to the oxygen. And now it'll look like this. And look, we're almost there. So this is pretty similar to the halogenation if you've seen my previous video. But it's where you steal this hydrogen and put the electrons down here, reforming aromaticity. So you can do that with a random water molecule, or you can also do that with HSO4 minus, which was deprotonated in the very first step. The lone pair of the oxygen can attack this hydrogen, and the electrons in the carbon-hydrogen bond here can go into the pi bond, reforming aromaticity. And now you have the final product and acid. To summarize everything, we have the formation of a strong electrophile over here, because this acts like an acid, this acts like a base. There's a good leaving group, so it leaves. And this thing becomes a good electrophile that's down bad for electrons, called the nitronium ion. And also the oxygens are very electron withdrawing, making it even stronger electrophile. Next you have the benzene weak nucleophile attacking the strong electrophile. Boom, and they get attached like this. This is the breaking of aromaticity, but it's also resonance stabilized. Now the final step is to deprotonate, to steal this hydrogen, and to reform aromaticity. Okay, that's it. Thanks for watching, and I'll see you next time.